Hey everyone, we're going to talk about molecules and compounds in this video. So a molecule is two or more atoms that bond together. They're going to be the same type of atom. And so here's an example of hydrogen. Oh, there we go. In a molecule form, this is also known as H2 or hydrogen gas. So when molecules or when atoms bond to other molecules, then they're called compounds. So an example, we have hydrogen gas, H plus O makes water, which looks like this. So that's a water molecule formed from three different atoms. Another example is sodium, which is a metal, and chlorine, which is a gas. When they come together, they make salt, which is what we put on our French fries to make them taste good. And again, that's just two different atoms coming together, making a compound. So these atoms come together and they form molecules or compounds via chemical bonds. So they have to bind together. A chemical bond is a relationship that holds two atoms together using some form of energy. And it's going to involve the electrons in the outermost shell or orbital. Okay, so we're only going to be looking at the atoms in the electrons in the outermost valence shell or orbital. And so the atoms closest to the nucleus are going to have the most affinity towards the nucleus. So think about this. In chemistry, as in biology, opposites attract. Think of a magnet having a positive side and magnet having a negative side. They come together and they stick together. So remember, protons are found inside the nucleus. Electrons are found outside the nucleus. Electrons that are closest to the nucleus are going to be attracted to the nucleus more than electrons found way out in a different orbital. They're not as close, so they're not going to be as attracted. When you take a magnet and you're bringing them closer together, eventually they'll snap together because they're so close. That's what I'm talking about, okay? So the atom or the electrons in the outermost shell, known as the valence shell, are the ones that interact in bonding. If the outermost valence shell is completely full, then these elements are considered inert. They don't interact. They don't want to gain or lose any electrons. All atoms want to have a full outer shell. So think of this. All atoms want a full outer shell. So if you are hydrogen, you have one proton and you have one proton and one electron. You want one more electron to have a full outer shell. That would give that first valence or that first orbital 2 electrons, which is how many it can have. If you only have one electron, then you're going to be more likely to enter into a chemical reaction. Helium is a noble gas. So these are both noble. Noble gases have a full outer orbital. They don't want to get into interactions with other atoms. So you can think, I said all atoms want a full outer shell. You can also say all atoms want to be noble. That's another way of saying it. if you have 2 electrons here, and then your next shell has 1 electron, you're going to want to either get rid of this electron or you're going to want to gain 7 more electrons, because the second orbital has 8 electron areas, so you can fit up to 8 electrons. If you have a third orbital and you have, say, 4 electrons in it, then you want 4 more, or you want to get rid of all 4. That's how atoms work. They want to have a full outer shell. So atoms will enter into chemical reactions with other atoms so that they have that outer valence shell full. So an example, hydrogen is one of our favorite little guys because hydrogen has 1 electron. It wants to have 1 more electron. So it's going to enter into a chemical reaction with any atom that is willing to share an electron with it. Carbon has 4 electrons in its outer shell, so it wants to gain 4 more electrons. Oxygen has 6 electrons in its outer shell, so it wants to gain 2 electrons. Sodium has 1 electron in its outer shell, so it either wants to gain 7 or lose 1 electron. So all of these atoms are going to enter into chemical reactions so that they can then have a full outer shell. And so when they do enter into chemical reactions, these reactions can either occur where you are completely transferring an electron. So one atom gains and one atom loses an electron. And then both atoms become charged, called ions. And they stick together because of that charge. And that is known as an ionic bond. Electrons are lost, so you're either losing or gaining an electron completely. Forming these ions. So let's look at what that looks like. Here we have sodium. I told you sodium has 1 electron in its outer orbital. It either wants to gain 7 or lose 1. It's easier to lose 1 than gain 7. Chlorine, on the other hand, has 7 electrons in its outer orbital. It wants to gain 1 or lose 7, right? So again, it's going to want to just gain 1. It makes sense. So sodium loses an electron and gives that electron, to chlorine, which you see here. So sodium has 11 protons in its nucleus. It gives an electron, because initially it had 11 electrons as well, but it ends up having only 10 electrons after it enters into this chemical bond. Chlorine has 8, 10, 17, that's what I thought. 17 protons in its 17 protons in the nucleus. But after it goes through this ionic bonding, it now has 18 electrons. That is so weird when it does that, right? So normally protons and electrons equal each other. Remember, protons are positive, electrons are negative. So in this process of removing 1 electron and giving it to another atom, we are producing an ion. And so the inside is positive with 11 protons. But now we only have 10 electrons, so sodium is going to be positively charged. Here the inside is negative, or has a positive 17, right? But there's 18 electrons, so chlorine has a negative charge. These two oppositely charged atoms are then going to stick together. So sodium ion and chlorine ion, or chloride ion, to stick together, forming sodium chloride, which is an ionic bond and forms table salt. So this one is called a cation. Cations are positively charged. This is called an anion. Anions are negatively charged. So then we have another form of bonding called covalent bonding, where we have a sharing of the electrons. So instead of me giving an electron to someone else and then sticking together, now we're going to share one electron or two electrons between the two atoms. So it's kind of like standing next to each other or holding hands with each other. There's an example. So covalent bonds are stronger than ionic bonds because you're actually sharing the electrons. And so you have one atom here and one atom here, and there's an electron that's moving around one orbital and then around the other orbital, and then this orbital and then this orbital, and that just keeps moving around each orbital like that because they're sharing. In a double covalent bond, you'd have two electrons moving around the orbitals. With a double covalent bond, it's going to be stronger. It's like holding two hands. Have you ever played Red Rover called, so-and-so over? If you're standing side by side, shoulder to shoulder, people are going to be able to break through that bond or through your wall pretty easily. If you're holding hands, they're not going to be able to break through as easily. If you were holding two hands, so they're not going to be able to break through it's going to be even harder. And so covalent bonds can also be called polar or nonpolar. If we are equally sharing the electrons, that's called a covalent polar bond, a polar covalent bond. So we have an example here where we have hydrogen atoms sharing electrons. The electrons are going to be equally moving around both hydrogen atoms. There's not a pull to one side or the other. Here we have carbon in the middle, but we have 4 hydrogens. Again, because of the structure of the atom, of all the atoms, there's going to be an equal sharing, so that's nonpolar. When sharing is unequal, then we form a covalent or a polar covalent bond. So in this case, one atom keeps the electrons closer to it. So let's look at oxygen and hydrogen. Oxygen here has 8 protons, it has 2 electrons in its first orbital, and then and I'm just going to make an orbital around so you can kind of see that's another orbital. It's going to have 6 electrons. So it's going to have a dot here, a dot here, dot here, dot here. We'll just go right here and there, okay? So there's 6 electrons. Hydrogen has 1 proton and it has 1 electron, right? So hydrogen wants 1 more, oxygen wants 2 more. So if oxygen makes a bond with hydrogen, now we still have, I'm just going to draw it here, we have 1 proton here, and again 8 protons, and I'm going to change the color, hold on. There we go. Let's change it to black so you can see. And we have 8 protons in this one, right? So we have 1 proton down here, 8 protons in the oxygen. Again, 1 proton. And we'll just keep it with red since that's what I did before. 1 proton there, right? So what happens is, I'll just use purple for funsies. What happens is the electrons, since there's so many more protons up here, the electrons sit closer to the oxygen. And so basically electrons don't stay in any given place. There's electrons orbit. So they move around the oxygen. They move around the oxygen. They move around hydrogen. They move around oxygen, 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 hydrogen, oxygen, 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 hydrogen, oxygen, 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 hydrogen. You see how it's staying up here? What that's doing is it actually causes the oxygen to be partially negatively charged because the electrons are sitting so close. So that gives this partial negative charge to the oxygen, and because they stay away from the hydrogens, we get these partial positive charges. So the overall compound here is neutral because they're all bonded, right? You still have a partially positive and partially negative charged region, and that's a polar covalent bond. So I'm going to stop here and we'll get into hydrogen bonding in our next video. Bye.